let me get through the curriculum introduction to give you a good idea of what we are going to learn and practice in the next 4 to 5 weeks. Okay. Um, so this course has runs for 4.5 weeks, and on Saturday, right? Today is day one, and we have 2 lessons. So we will be focusing on generative AI introduction and prompt engineering today. I'll give everyone an introduction to generative AI, the landscape. I'm sure you have lots of questions, so feel free to ask questions. Let's try to make this as interactive as possible. Um, After the introduction to Gen AI, I'll introduce large language modeling, and we'll discuss how to adopt generative AI at work. I think a lot of our alumni or the new students in this course, you guys, work for different companies. I'll be very curious to know how your company think about, adopting generative AI at work. I know, like in the banks, it's most likely it's banned, right? They don't allow you to upload anything to ChatGPT. So how do we solve that problem if the banks or heavily regulated companies want to use generative AI? I'll share some of my experiences and my thoughts on this as well. And this afternoon, we will learn the basics of prompt engineering. I guess like some of you or many of you might actually be much better prompt engineer than myself. I haven't, I use ChatGPT regularly, but I wouldn't call myself like a power user. But I'll at least share what I've learned in the past with you, sort of more from a theoretical background perspective. Okay. And then we'll do lots of exercises. So that's what we're going to cover today. Day two, we'll cover more specific use cases, and we do need to discuss the ethical use of generative AI. There are lots of issues about privacy, bias, and all of those stuff. So we'll discuss that. And day two, we might actually start to discuss the mini capstone project we need to do in this course. Okay. So we'll begin with the general use cases. We'll talk about different use cases like marketing, procurement, HR. We'll talk about ethical use of AI, compliance and regulations. Okay. And day three is about no-code ML and no-code AI. So I think if this course is just teaching you prompt engineering, it's not that useful. So for some of you who come from data, so by the way, this is the first cohort. We've done this training to some other institutions like, the government and some other partners. But this is the first time we're doing this, publicly. So we have students who paid for this course, but we also have, I think, alumni or students in the current boot camps. So you may come from like different programs, BI, data science, data engineering. I think for the data science students, you know how to train machine learning models using Python. But many other students probably have never done machine learning in the past. So I'll introduce no-code ML. I think this is a trend. It's going to become more popular. So yeah, even for the bootcamp students who have completed some data science work, I think this will still be a very helpful review, and you're going to learn some new tools. Okay, so I'm going to give everyone a very high-level introduction to machine learning. There won't be a lot of theory. And then we'll introduce no-code ML and no-code AI tools such as Amazon SageMaker Canvas. We'll introduce NIME as well, which is really awesome open source free tool. Okay. And then we will start AI automation on day 4. For me, this is probably the most useful part of this course. Because I think if you just want to use ChatGPT for like ad hoc and daily usage, that's fine. I think you don't need training on this. You'll just get better over time. There are a lot of prompt templates out there. But I think if you seriously want to gain productivity at work, I think you need to learn how to use AI to automate the workflow, right? So, of course, we can prompt ChatGPT to do translation, but what if you have 5,000 documents you would like to translate? Of course, you can use Python, you can call OpenAI API, but I think there's some really awesome workflow automation tools such as Microsoft Power Automate. There's Zapier, So we'll introduce both. Zapier is very popular, but hopefully we can come up with some really awesome ideas in this course and build some really cool stuff that automates things. So yeah, you will still be working with. I think OpenAI will provide the API key so that you can use Zapier to automate some stuff, and that will help you become more efficient and more productive if your company allows you to use it. But even for for personal usage, I think this can be useful. So we'll cover AI automation tools, Zapier, Power Automate, and Eric will focus more on the Power Automate side. And then we'll discuss the capstone project. You have about a week to complete the mini capstone project, and the presentation will be on day 5, which is the 30th of March, end of this month. Okay. So this is what the curriculum or the schedule look like. So today, March 2nd, we'll cover the first 2 lessons, demystifying AI and Gen AI. We'll talk about prompt engineering. And next week, on March 9th, we'll focus on use cases and ethical use of AI. Each lecture is basically 3 hours. And then March 16th, we'll cover no-code AI. And then March 23rd, it will be AI automation. We'll start the brainstorming, of your project maybe later today or next week. So you have 2 to 3 weeks to prepare for the capstone project. Okay. And I'm going to introduce the roadmap for you in case you are more interested in the technical path. If you want to get more into like large language modeling, building, RAG and some of those applications. That's what I'm going to talk about next before we kick off the lecture. Okay. We use Slack for communication. So if you have any questions, you can ask them on Slack. All right. So that's the Q&A and communication. And then in terms of the support, you can ask, questions during the class on Zoom, right? You can raise your hand, unmute yourself, or just ask question in the chat. After the class, again, the Q&A doc and questions on Slack. You'll get a certification after you finish the capstone project. So that's the only requirement. There's no assignment exercises. But we want you to be able to sort of, finish this course, building a pretty cool AI automation or no-code AI project. So you can choose to focus on no-code ML, or you can choose to focus on AI automation. And we'll discuss this. Okay, you just need to pass the 70% mark to get the certificate. There's some sample like use cases from the other cohorts, like, or other clients we have worked with in the past few months. So we've seen some interesting like use cases, for example, generating a Google to-do list from new Google Calendar events. So it's sort of just using Zapier to integrate with Google, Calendar. And then, we've seen people automating, for example, IT like workflow, like whatever approval process. There's someone who's like IT manager, and he gets all kinds of like emails from the team members, asking for vacation approval and things like that, and he's trying to automate that process using Zapier. So connecting Zapier to Gmail or whatever company email and then use ChatGPT to summarize, or either summarize the email or extract useful information. And then he has some sort of built-in logic to help help with the approval, and then it will like send a response. So I think that's a pretty cool idea. But I'd love to see what new ideas can come out of this class. Okay, we have worked with researchers and PhDs who was really interested in using ChatGPT or any kind of large language models to automate like the translation and summarization of research papers that requires a little bit of web scraping, and then they summarize everything to a Google Sheet or Google Doc. So that's just to help themselves become more efficient, I guess. So yeah, interesting ideas, but we'll have discussion maybe later today. Okay. It's time to start thinking about it. Okay, now I would like to point you guys at the right direction because we have students coming from different boot camps and or students who's only enrolled in this course, and you all come with different objectives, right? We'll discuss the objectives, but I sort of just summarized some of these and share the learning path with you. Okay, if your goal is to just get familiar with generative AI and then evolve sort of into AI engineer. This is the general path. So first of all, I think you need to become like a more you need to be familiar with prompting, right? Just become a user, a regular user of tools such as Bing, ChatGPT, or Gemini on a regular basis, right? So learn the basics of prompt engineering and prompt design. I think that's a skill set that everyone needs to know, need to have. And then to boost your productivity at work, you might be working for a company or you're running your own small business. And I think AI automation is really going to help you. So try to increase your productivity. If you work as a data scientist, data engineer, I think tools like ChatGPT can help you write some like starter scripts and code, and that's super helpful, right? But if you want to go beyond that, right, and you need to sort of be able to fine tune or customize these large language models, then you need to have data science and machine learning fundamental knowledge, right? So you need to take some data science machine learning courses, and instead of just directly prompting ChatGPT, maybe learn how to use Python to interact with a large language model through API, right? That's the first step. And then you need to learn the basics of deep learning and AI, just working with different libraries such as PyTorch, Hugging Face, and understand the fundamentals of transformer architecture, what is encoder, decoder model. These are some of the LLM basics you need to know. And then the most useful part, of course, is just learn how to fine-tune models and build LLM-driven applications. Okay, so this is a simple learning path, but I'll get more specific on the next few slides. So in the world of AI, I think there are some very specific use cases. For example, computer vision, NLP, large language modeling. These are, the techniques used behind are all part of deep learning. Deep learning is part of machine learning, so we'll discuss that today. But if you want to get more specialized in computer vision, you need to, again, start from AI and ML fundamentals, right? Learning PyTorch, Hugging Face. And then you need to know how to process image, not just image, but 3D LiDAR data or vision data, like video data as well. So image processing, data processing, annotation, these are very important skill set. And actually just calling the API to use a model is pretty straightforward nowadays. And most of the differentiation is actually in the way you process data. I think OpenAI has sort of been the leader in the market. It's not just like as someone said, like there's not much innovation in their algorithms, but it's the computing power and also the way they prepare their data. So the data is still proprietary, even though when companies open source large language models, they open source. It's not pure open source, right? They open source the model weights, so everybody can use their model. For example, like Facebook's Llama model. But they just don't open source the data preparation part because everyone knows that that's the key differentiator. So if you want to become really good and specialized in AI, you need to be very good with data. Okay. Yeah. So after the data and image processing, you need to learn the basic, computer vision stuff related to deep learning, which is convolutional neural network and different architecture. And so CNN is considered as a little bit like old now, like it's been around for many years, but it's still one of the most commonly used. And there's graph neural network, but the most recent breakthrough is probably in, for example, everyone has seen Sora. It's based on, transformer architecture, but it's a multimodal model. We'll discuss that later today. So yeah, you need to learn vision transformers as well, and then understand different use cases. I think it's the use case that's more important, right? How do you use computer vision to do object detection, image segmentation, instance segmentation, and things like that. And then, of course, you need to learn the generative models, which is using text prompt to do text to image generation or image to image generation. There are lots of use cases. So that's just a general learning path if you would like to get specialized in computer vision. I think more people will be interested in large language model, LLM, NLP right now. It's super hot. But I think in the next couple of years, computer vision space is going to, explode, and because there are a lot of things that we cannot do through simply text. And that's why multimodal models are more becoming more popular. So it might be a good time to invest on some effort in computer vision and become specialized in it, because you can I think we can achieve way more powerful models through computer vision instead of just text. Okay. And yeah, if you want to build some advantage in the job market when it comes to data science and AI, then LLM is something you will need to be familiar with, right? At least know how to use it. And there are different levels of expertise. But my suggestion here is that always start from data. Obviously you need to know the basics, right? The AI fundamentals, neural networks, and things like that. But you need to know NLP basics, right? How to pre-process data, text data, how to annotate text data, data scraping. And these are all very important because if your company wants to build customized large language model solution, then you need to know how to collect data and annotate data, okay? And the secret sauce is usually in the data, not the model itself. And then you need to learn transformers. This is still by far the most popular architecture. Some people, there are two different camps. So one side that's really believes in transformers, and they think there's a lot of new potential as well. But there are also people who sort of think that transformers can only get you this far, and new type of models and algorithms are required to help us truly achieve AGI. I'm not those experts, but I'm just listening to both sides and just decide what's more important for us right now, okay, and next couple of years. After transformers, I think you need to learn large language model. I don't think anyone needs to become an expert in LLM. This field is evolving so fast. It's kind of hard to even keep up when you need to build like course material and content, right? But I think my recommendation is just focus on data processing, data cleaning, and data augmentation. That's different from what we learn in a data science and data engineering course, because most of the time we're dealing with structured data. We're still dealing with like SQL and stuff, but LLM is very different. We're dealing with unstructured data, text, images, and the way we clean and deduplicate these data is very different, and it requires different of skills. And most of the time, you don't even have enough data and label, and then you have to do data augmentation. So these are some new techniques you need to learn. If you want to become an LLM developer or AI engineer with a focus on natural language processing, you absolutely need to learn data augmentation and pre-processing, okay? And then, of course, you need to understand different types of large language model applications, right? There are encoder-only models, encoder, decoder. If you're not familiar with these, these terminologies, don't worry about it, because I think we have people coming from very different backgrounds in this course. Some of you may understand what I'm talking about, but this is really just a learning path. When we move on to the lecture today, we'll start from scratch, okay? And then the best I think usage of large language model right now is just fine tuning or building RAG application. Because a lot of companies can't really allow their employees to upload data to, for example, OpenAI and use ChatGPT for to sort of analyze their private data. So in that case, those companies will want to bring large language model in-house, which means they're going to be working with open source large language model. Or if your company has a lot of money, then you work with ChatGPT to bring the enterprise version on-prem. They do that, but the cost is insanely high. Not a lot of companies can afford that. Okay, so that involves like fine-tuning a large language model to be able to understand the context, right, or understand your proprietary data. If you want to use let's say ChatGPT like technology LLMs to analyze all the documents in your company, right? And there might be like hundreds of thousands of documents. So in that case, we either have to fine tune these models, or we'll have to build different type of knowledge base in order to make that work. That's probably the most actively developed areas in big companies, and everyone's trying. And people are less likely to build their own large language model. So you have to understand this, like, because the cost of developing a large language model is very high. So most of the companies will be able to fine tune these models and tailor it to their own use cases. And for the big models, let's just leave it to OpenAI, Google, and all of those open source models. Okay, so that's the learning path if you would like to get more specialized in LLM. If you come from data engineering, software engineering, DevOps background, and you're not really into data science and these algorithms, I think my recommendation is you focus on building applications. For example, RAG is, it stands for Retriever Augmented Generation. It's sort of like just building a knowledge base. If you have a lot of text, a lot of documents, you can save them in a vector database. It's like just storing all of your company's data in a database. But here we're not talking about relational database. We're talking about indexing or saving all of these, text data documents in the vector database. And then you just need a more efficient way to retrieve the document that's relevant to the queries. You're not going to do exact match. When we write SQL queries, right, we'll do something like, select star from where country equal Canada, where country equal United States, right? You're doing some sort of exact match. But with large language models, you can't really do exact match because even with the same meaning, people can say things in different ways. Even one word difference is going to cause the data index to be very different. So in this case, we're going to do the vector similarity calculation. We'll briefly talk about that later, but that's what you need to learn. So that involves different set of tools, using LangChain or Llama Index to ingest data into the vector database, tokenization and chunking the documents when the document is really long, working with a different type of database, which is vector database. I think data engineers in the future all need to be familiar with vector database as well. Yeah, so that's RAG. And it's very, very commonly used in the industry, and most of the companies are trying to adopt this. And also AI agents. If you want to build cool applications, right? We'll talk about AI agent and the difference between that and ChatGPT. But yeah, so there's some cool stuff you can build, but I think it's still kind of too early. Not that many companies can use this actually in production. Okay. And then if you want to get more specialized on the operation side, then LLM ops or machine learning operations, these are also very hot right now. So you need data engineering skills, right? Automate your data and ML pipelines, building feature store. Data governance is important as well. On the ML engineering side, how do you scale model training, right? When you have lots of data, and how to track experimentation of all of your ML models, model packaging and deployment. So yeah, I'll share this slide with you. I won't spend too much time on this today, but in case you're interested in knowing like, okay, what's the next step, right? You need to understand your own objective first. Why are you taking this course? And um, what do you want to do in the future, right? In terms of generative AI or just AI in general. And there are different paths you can go down. Okay. All right. So now this is, I think, the last slide for my introduction. Um, Let me share this link with everyone. We're going to do some interactive exercise together. And I just want to get some of your input. So please click on this link here. Okay. And I'd like you to tell me your learning objective. You can just write your objective on one of these cards and you can duplicate them as well. Okay. You can copy and paste. Let's, it gives us an opportunity sort of just to understand, what everybody else is thinking about this course and why they want to do this. All right. As you guys keep, adding information, I'll start to go through some of these, and hopefully that's useful for everyone. Okay. So, okay. First one here, data analytic learner. So we have a student from data analytics background, don't know much about Gen AI, need some guidance. So I think this course is definitely going to help you to build the fundamental knowledge about Gen AI. So that can be very helpful. Use knowledge from this course, how to automate existing tasks, processes for increasing productivity, protect future job security. Okay, yeah, so this is related to AI automation. That's what I think is the most interesting part of this course. So I definitely think that you will be able to achieve the goal. And yeah, please spend some time on the capstone project. Some students here to learn no-code AI for data science. That's great. I think we're going to learn some new tools. So it's definitely going to help you even if you already know how to build machine learning models using Python. Okay, become familiar with AI for automation. Understand AI jargon. Okay, cool. So I think today's lecture is going to be very useful if you want to understand the jargon. Curious. BI bootcamp student with beginner level knowledge of all applications. Don't understand anything in this Gen AI curriculum currently. So welcome to the course. The goal is to, after the camp, become a DA. Okay. I think if your goal is to become a data analyst, Gen AI tools can really help you. ChatGPT even has some data analysis tool, and I know the new Microsoft Excel tool allows you to sort of do prompting and then write Python code for you. There's like way more powerful version of Excel VBA. So we'll discuss that. Okay. Learn how to use ChatGPT to my advantage. Yes, I think this is going to help everyone. To gain deeper understanding, nuances of prompt engineering, fine-tuning, indexing, RAG, comparison of open source LLMs versus AWS for low code. Okay, cool. Yeah, if you're this course, we will not be teaching fine-tuning and RAG. That's more technical. So if you're interested in like fine-tuning and RAG, we do have an LLM course, which is more targeted towards data scientists or machine learning engineers. But we'll discuss a lot of those today, at least at a very high level. And if you want to learn more, feel free to ask me questions during the class. Okay, I'll try my best to cover as much as possible. Gain knowledge and experience. I have a general overview of Gen AI. Yes. Catch up with the modern job market trends. I think adding some Gen AI keywords to the resume will definitely help. So even using that for like job search, writing resumes, even responding to hiring managers' emails, I think this will definitely be helpful. Be competitive as a data scientist. Yeah, I think if you want to get become more competitive as a data scientist, what this course can bring to you is the no-code AI and AI automation. But that doesn't help a data scientist to build like a very strong unique advantage. But that's something that will really help you. But I think you need to dive deeper into LLM and natural language processing. Okay. Be more efficient using AI, ChatGPT. Be more efficient. Okay. Be competitive. Update on latest technology. General understanding. Okay. So I think people are here for either just learning more about prompting and becoming more efficient. There are a group of students who there's a group of students who want to just learn more about all the terminologies, the jargon, catching up with the trend. There are folks who are here who want to learn more about the more technical side of things. And what is this? Vision AI, know about future trends related to data, have interest and career combined. Use a tool about AI to be more competitive to my work. Okay, cool. Thanks for all of your input. I hope this is useful. This is helpful for me as well to understand what everybody wants to get out of this course. So I think if you want to learn like the jargons and the trend, today's lecture will be very helpful. Day 3 will all about AI. Oh, sorry, day 4 will all about AI automation. We'll talk about that on day 3 as well. Prompt engineering, we'll talk about the theory, some of the theory and just the methodologies. We'll cover that today in the afternoon. Okay. Cool. Now let's get started. I have a ton of slides. As I said, you need to get your coffee ready, and we'll take breaks. Okay. We're already 40 minutes in, so we'll take a short break very soon. Lesson 1, let's demystify AI, okay? First of all, I think AI, sometimes machine learning, deep learning is kind of confusing. Right? I think our data science students will know this better. First of all, AI is broader. It's usually tied to an industry or very specific use cases like AI in healthcare, AI in robotics, right? AI in manufacturing, and whatever machine learning, large language model, these are just like a very small part of AI. It might be used in machine learning is used in self-paced driving, but AI for autonomous driving is much broader topic. Okay, it's not just machine learning, and machine learning is part of AI. And when people talk about machine learning nowadays, I think they're referring to like the classical machine learning algorithms. We'll talk about like supervised learning, unsupervised learning, and anything that's more specialized, or more related to neural networks, that's deep learning. And deep learning is a subset of machine learning, and with a focus on deep neural network. Neural networks is just one specific, family of algorithms that's used in machine learning, and people have been doing this for so many years. Okay, but there are other types of machine learning algorithms, supervised, unsupervised, tree-based algorithms, and genetic algorithms as well. And deep learning is based on neural network, and it become very popular because it allows you to actually handle a much bigger data set, and then you can use it to its full advantage to train something that cannot be handled by the traditional machine learning algorithms. And most of the breakthroughs nowadays is based on deep learning. Okay. And then if you dive deeper into deep learning, then there are different use cases, right? People use it for computer vision, people use it for natural language processing, and generative AI is a specific use case of deep learning. It's built on top of deep learning. I think at least today's Gen AI, algorithms, right? And most people think Gen AI is just ChatGPT, but it's not. There are different kinds of generative AI applications. You can generate image. Now with Sora, you can generate videos, generate text. We'll discuss more about this later, okay? Inside Gen AI, then there's the large language model, LLM, okay? And it's, it's closely related to NLP and generating text. And I think everybody get to know about Gen AI because of ChatGPT, and that's one specific use case of large language model, okay? So We'll peel the onion today. We'll go through this step by step just to help everyone understand the relationship, among these different concepts. And I'll give you some concrete examples to hopefully help you understand the similarities and differences. Okay. If you have any questions, just let me know. You'll notice that I may skip some of the slides because I think it's just good for you to read about them, and I'll just talk to some of the important points. Okay. All right. So as I said, AI is more tied to real life applications, right? Machine learning is something we talk about more often, and it's a subset of AI. And when people say AI nowadays, what they mean is just machine learning. Most people say, okay, AI, that's basically they're talking about machine learning. Okay. Um, there are different types of machine learning, supervised learning, unsupervised learning, and I'll give you some examples. Okay. So a machine learning system, you can think of it as a black box system. It allows you to perform some tasks. For example, we would like to classify images. You have, thousands of images, and you would like to label these or classify these images, whether it's, a cat image or a, dog image. Human can do this really well, right? You don't really need any machine learning system to do that. But the reason why we need machine learning is because we want machine learning to help us to automate things. These are like very repetitive tasks. And what if we can have a machine learning system that can learn how human, interpret these images, and we automate that process so that we can scale that to millions of images, and we don't need human to do that manually anymore. That's the whole point here. It's just for automation purpose, right? But of course, it's not always perfect, right? Maybe it can achieve 98% accuracy, but still it makes mistakes. Even ChatGPT is, far from being perfect, right? A typical ML systems requires input, and it gives you some sort of output, right? So input, and you feed the input into a black box system, and then gives you the output, right? Okay, here's one example. We have some images, right? We have, let's say, a blueberry muffin picture, and we have a Chihuahua picture, and then we feed these input into the machine learning system, and it's able to do prediction. That's the output. So the ML model is going to generate the output. So it can classify images, and it can tell you whether it's blueberry muffin image or it's Chihuahua image, right? But how does this work? How is such kind of model built? Okay, and it's basically learning from many images, and it's learning the rules. So it needs to learn from examples. If you only have one picture of a blueberry muffin and Chihuahua, it's not enough for the machine learning system to tell. Like the next time, it may actually just predict something that's totally random, right? Because it only has seen one example. Okay. But the more examples we feed into this black box ML system, right, it actually starts to learn. Now, there are different ways for a machine learning algorithm to learn. And now we're talking about like different kinds of machine learning algorithms, right? Well, decision tree algorithms, linear regression, neural network, and deep learning, which is some of these algorithms, okay? And these algorithms are built in different ways, mathematically, so that it can apply different ways to learn the differences or similarities between Chihuahua and blueberry muffin. Okay, we sort of automate this process. Now, maybe we can just hard code these rules, right? Okay, we can define some rules and say, if the image look like this, then this is definitely a dog. But there's no rule that can be so perfect. You need very complex rules because as you can see, even humans sometimes may get confused. Okay, so you can't really have rules that can, take care of all of these differences, right? And that's why you need an engine to sort of can learn and make inference based. So you need a more scalable way to learn these rules automatically. That's what deep learning and machine learning are all about. Okay, and the better algorithms will be able to learn these rules, better. Okay, and the more examples it sees, the better it gets. And most of the machine learning algorithms are pretty data hungry, right? And especially deep learning. it needs to see thousands, hundreds of thousands, or even millions of examples, and it becomes smarter and smarter. Right? We'll talk about LLMs. These large language models are trained on terabytes of data using trillions of parameters, or so it's pretty massive, and that's why it requires a lot of GPU, computing power, and it's quite expensive to train these large models. But I've heard people asking, okay, so now we have ChatGPT, we have Google Gemini, do we still need to do machine learning? And the answer is absolutely yes, because I can't imagine people using, well, at least in the next few years, I can't imagine companies using large language model to replace the traditional machine learning. You know why? Because the cost is very high and it's not going to be that reliable. And for most of the businesses, they not only need something that's very powerful, they need something that's scalable, and they want to do that at a cheaper price, right? So using ChatGPT to, let's say, generate prediction for hundreds of millions of Facebook or Meta users every day, and they do that multiple times, that cost is going to be insanely high. And also LLMs are usually very slow in terms of generating predictions. It might take 500 millisecond, or it might take a few seconds to generate predictions. Right? And it's not going to meet a lot of the use cases in different companies. For example, when you do fraud detection, you need something that happens in real time. And you're hoping that the latency could be within 10 milliseconds and to generate the prediction. But if it takes 2 seconds, it's just too slow, right? So that's why most of the industry use cases are still going to require data science and machine learning skills. It's not always going to be large language models. And unless one day the cost of running LLMs is going to become extremely cheap. I don't know when that's going to happen, because if you look at NVIDIA's stock price, it's even bigger than the FANG companies now. And that tells you how much we're relying on compute, right? So it's still quite expensive to companies to train and use large language models. And the usage actually costs more. Okay, if you look at NVIDIA's revenue, actually half of them come from just making prediction, not just training the models. And that's very interesting to know. Okay. All right. So the machine learning system, when you feed more examples, right, it's going to start learning better, because at the very beginning, when it only sees 2 pictures, and maybe it's 50-50, it's doing, and then when it start to see more pictures, it start to have more confidence. On the right hand side, you'll see like the 35%, the 65%. These are the confidence level, right, or the likelihood. So it start to become more confident as it starts to see more examples, and your models start to become smarter. Okay, and in the end, you want to feed it some sort of unlabeled data, and it can generate predictions. Okay, if this is the very first time you're getting exposed to machine learning, I'll just do this as a demo, but you can click on this link to build your first machine learning model. Okay, for the data science students, this is probably way too easy, but it's something fun to do. Okay, so you can go to this link. It's called Google Teachable Machine. I send it to Zoom chat. And then you can click on Get Started. I believe you don't even need to sign up for an account. Okay. And what I'm going to do here is, let's say we do image. I think they have like audio post project. I think the post project is probably more interesting. But I'll do the image project because I have the data. Okay. So you click on image project. There, you can do the standard image model. You can do the embedded image model. The embedded image model are usually much smaller, and you can use it on the edge device like a microcontroller. But in this case, let's just choose the standard image model. Click on it. Okay. And now you see a simple ML pipeline. You need to feed data. And here it's image classification. So you need class 1 and class 2. Class 1 can basically be Chihuahua image. Class 2 will be blueberry muffin image, right? So you can either turn on the camera to capture your own picture, or you can upload the data set. Where do you get the data set? You can download it from this link. It's in the slide, but let me share with you. So in this Google Drive, you can download a couple of like Chihuahua and blueberry muffin image. I believe it's public. If you cannot access it, let me know. Okay. All right. So I'm going to let me download this. All right. Now I'm going to upload some images. So we need to give, as I said, we need to give a machine learning algorithm, right? Examples. So the data needs to be clearly labeled, so it knows that okay, the image you upload right now are blueberry muffin images, right? So let me upload that Chihuahua. I'll upload, let's say, the Chihuahua images first. I have 3 of them. Okay, Chihuahua 1, 2, 3. And now image got uploaded. I can change the class to be, let's say, Chihuahua. Okay. And then for class 2, that's basically blueberry muffin. Okay. And let me upload the blueberry muffin images. All right. So basically, without writing any code, we constructed 2 data like 2 data sets, right? One is for the Chihuahua label, the other one is for the blueberry muffin, and then we can move on to the training stage. Training a model requires some sort of algorithms and parameters, right? If you're a data science student, you will learn how to do that, but it's not important for today's discussion. I just want to give you an overview of what happens, right? But you can choose some parameters like epochs, like how long you want to train the model, the batch size, the learning rate, and then you can click on model training. It actually starts to run a machine learning model training process in the background. And in this case, it's very fast. So it's already done, and it can like preview the model. But I'm not gonna upload my personal picture. Well, it's predicting me to be Chihuahua instead of Blue Muffin. Well, I think it does a pretty good job, but still, we don't have a human whatever label in this, right? But you can instead of the webcam, you can upload data for it to generate prediction. So again, change from webcam to file, and I have 2 images. I call that classify. So these are the images used for prediction. I know this is a Chihuahua image, but you can see that in the output, it says 100%. So it's pretty confident that this is Chihuahua. And how about the blueberry muffin image? And it's 100% blueberry muffin, okay? So when people talk about the limitation of ChatGPT, and here, this is actually one example. I think people was trying to sort of upload some Chihuahua and blueberry muffin images, and I think in some of the examples I've seen, people say that it actually wasn't correctly predicting the blueberry muffin image. But I tried myself, it seems to be perfect. So anyways, so that might be your first machine learning model train. I hope you had fun. But again, all I'm trying to help you understand is that a machine learning system takes input. So it needs labeled data so it can learn from those data, and then it becomes a machine learning model, and you can use the model to generate the output. The output is usually, just some sort of prediction. Okay. All right, we're gonna move on. So that's a very brief introduction to ML. And then deep learning. Deep learning, as I said, is a subset of machine learning, and it's usually related to artificial neural network. It's just a machine learning algorithm and also architecture that people use to learn from images and text data, but you can apply deep learning to structured data as well, and has been quite powerful. Okay. My personal experience, Deep learning is very specialized in, text processing, NLP, and, computer vision. But if you apply deep learning to very structured data, like for example, if you use it for customer churn analysis, it's not always going to be better than the classical algorithms like decision tree or XGBoost. Like may as well just be outperform a neural network. And it's unfair to say that deep learning is not as good as XGBoost on some of these data. It's more about how complex the problem you're trying to deal with is. If you're using deep learning and machine learning to predict customer churn, it's actually a quite simple problem. Like maybe the process, right, of generating a very accurate model is still very complex, but the problem on its own is not a hard problem because, if you're, let's say you operate like a telecom and the customer or bank, customer leaving, there are only a few reasons why people churn. It's either the customer, they had really bad customer experience, or your competitor has better product or they have better rate. If you go for mortgage and then you can't get the rate you want from your own bank and you go to another bank and they give you a better rate, and then maybe you might as well just move all of your balance to or whatever, savings to that bank that gives you the mortgage. It's totally possible. So there are probably there's less than 10 reasons why people want to learn. And when we give the data, training data to the deep learning, machine learning algorithm, it just tries to learn the latent space. Like, what is the real reason why people are going to churn? And if you do something called dimension reduction, it's probably just going to be reduced down to less than 10 factors, because it's trying to mimic the real life. It's not going to come up with more reasons than the real reasons that's causing people to churn, right? So if you look at this, the problem is not that hard. And we spend a lot of effort in machine learning using different algorithms. We do dimension reduction. It's just trying to learn these implicitly. So in that case, it doesn't actually require a ton of data. It doesn't require very complex systems. So deep learning may not outperform the classical machine learning algorithms. And we know that deep learning, the cost of using deep learning is actually higher because it has more complex architecture. So when it comes to generating prediction, it might be slower. It could be 200 milliseconds slower than a linear regression model or logistic regression model. And that 200 millisecond difference in speed is going to make a huge difference in a production system, because if you're thinking about the YouTube video recommendation or TikTok, whatever, sometimes they don't use very complex machine learning algorithm, because it's not just you who needs recommendation. It means 500,000 people might be on YouTube right now. They all need recommendation. So that requires a lot of computing power, and 200 millisecond difference in one prediction is going to add up. Right? That's going to make the system really slow, and the user experience is really bad. And sometimes the user experience is way more important than the accuracy of the model, right? So there's always room and space for traditional machine learning algorithms. Even as advanced as ChatGPT is, very small use case in real life. It helps everyone become more efficient, but if you want to apply that on any specific business use cases, you might as well just use the traditional machine learning. So it's going to be around for much longer than you expected. Okay. And the cost of using ChatGPT is just simply too high. All right. When we talk about deep learning, we have to put that in the context of use case, right? So what do you use deep learning for? As I said, it can be used for the traditional prediction tasks, but you might as well just use machine learning or the classical machine learning algorithms. And deep learning can do really good job on computer vision, for example. So you can do image classification. We've seen that example, right? But you want to do maybe object detection. And you may want your computer vision to automatically detect objects in a picture, right? It can do image captioning, generating description for images. So you can upload an image and ask, for example, Midjourney or DALL-E to summarize the picture for you in text. I think these are really good use cases, right? It can, again, think about automation. Machine learning, the whole point, why do you want to do it? Because you don't want to do things manually and you want to scale that, you want to automate that. And that's why we use deep learning and machine learning. And of course, we have to tolerate the imperfection of these models. It makes mistakes, right? And this is another example for semantic image search, right? So you can click the link here, but basically this is a website that curated a lot of images and they're pre-trained models, and you can basically upload your own image and it will quickly find similar images. So I think there are a lot of real life use cases to this as well, okay? I think we did a small project for one of the startups in the past. They basically have a ton of like furnitures, right? Sofa, bed, and curtains, and they have all of those, right? Different colors, different shape, different brands. They want to first they want to index all of these images in their databases, and then they want the customer or the client to be able to upload images like, this is the sofa I like. They just Google and find their own sofa, or even just take a picture of their own sofa, and then it allows them to search for similar sofa in similar style in their catalog, right? So that's a very useful use case, and that's basically image search or semantic search. And yeah, but at that time, that was like 4 years ago, and the computer vision algorithms are not as powerful as today's, and we tried our best, but it's still not the best model, I can say. But you can easily adopt some of these vision transform models to do way better job. Okay, so this field is evolving really fast. The Chihuahua and Blueberry Muffin example here is basically an image classification example, right? So instead of using the traditional machine learning algorithm, we use a deep neural network, and there are different architectures, convolution that's based on something called convolutional neural network. We'll briefly talk about that later. Okay. Okay. So what makes deep learning better than the traditional machine learning in some of these specific tasks, right? It's because it does something called data representation better. So when you think about the machine learning algorithms, right? As I said, it's trying to learn rules, right? The simplest rule we can build is handcrafted. We just write if and else logic, right? Okay. So, but we want to automate and scale this process, right? In the traditional machine learning, we do something called feature engineering. We'll come up with like smart features, okay? And then using these features, we can use that to generate predictions. Okay, if we want to predict customer churn, maybe we can craft, features such as the call volume. Has it decreased in the past? Or has the user stopped using some service? Or has the user had like some sort of complaints in the last 2 months, right? Or was the bill like all of a sudden like increasing by 200%, so the customer is not happy about the bills? And these are the features that we can create, right? Applying that to those kind of use cases, it works really, really well. But when it comes to computer vision, we're just looking at this like, 2D or 3D images, right? It has 3 different color channels, but the image is represented basically using NumPy arrays, right? Using some sort of arrays, and it's pixel by pixel. How can we represent an image in a way that the machine learning or deep learning algorithms can understand these images, right? People used to do, again, manual feature engineering, just like the way they do traditional machine learning, and it doesn't work out very well, right? And that's when we had the first breakthrough, when convolutional neural network algorithm came out, because it automatically extracts features. And this is something called representation. It's either image representation, it could be text representation, depending on the use cases, right? So we are still using deep learning or any kind of machine learning classification algorithms to train the model. But before we train the algorithms, train the model, there's one step that does feature representation. And that's convolutional neural network. That's the convolution steps, right? In computer vision. Okay. So representation is very important, and you need to learn different kind of architecture, different ways to do this kind of feature engineering automatically. Okay. Deep learning has use cases, a lot of use cases in NLP, and large language model is just one very specific use case, right? It does some sort of it can help you generate text. But people have been using the classical deep learning and machine learning algorithms for various tasks, right? Such as generating sentiment analysis, predicting if the tweet is positive or not. And companies will use this for analyzing the sentiment on the internet about their product. And that's a very common use case. Named entity recognition, like extracting useful entities from text. So for example, when you do job posting analysis, maybe you can, upload the job description to ChatGPT and ask ChatGPT to extract useful keywords so that you know what this job is, like the requirements of this job, right? You can do this just for your own use, but if you have lots of text that you would like to do data extraction, then you either have to work with the ChatGPT API, or there are named entity recognition algorithms out there that's based on transformers or LLMs as well. Okay, we can do machine translation. I think I hope this is easy to understand, but LLM is something we're going to focus on. Okay, so right now it's just a very high level overview of what these are. Okay, before we take a break, I just want to take you through this example. I think the data science students may have seen this in the past, but if you come from other background, I'm going to help you build your first neural network. Okay, let me share the link with you. Okay. The link is basically playground.tensorflow.org. This is a JavaScript-based machine learning like tool. You can basically choose different data sets. So on the left-hand side, you'll see that they provide 4 data sets. Okay, and on the right-hand side in the output, you will see how the data points are represented. Okay, so for example, this is called I think the circle data or something, and basically the data points have 2 different classes. It's either orange color or blue color. It's just like the way we classify chihuahuas and blueberry muffin images, right? But here we're just predicting the color of the data points. So these are also called labels. Okay, so that's the data. And then we need to represent the data and build the features. Right? So in this case, we're training the neural network models because it has 2 axes, right? X1 and X2. Okay, so this is X1, this is X2. So for each data point, we can basically represent using a tuple, right? X1 value and X2 value. And that's basically one row. You can think of it as one row in the Excel spreadsheet. And if we have 100 data points, then we have 100 rows, right? Okay, and then we're going to build a very simple neural network, right? A neural network has 2 different things. It has something called neurons, okay? You can add neurons. It mimics like the human brain. We have neurons and we have, and there are different layers, right? And, I'm not going to go into the too much technical jargons here, but this is how we construct the neural network to mimic, for example, the human brain. So I can click on the plus sign here to add more layers, and that makes this neural network deeper, right? And it's so-called deep learning because it has a lot of different layers. And inside each layer, you can add the number of neurons, okay? You can make it very complex, but of course, it's going to take a longer time to train the model, okay? And there's infinite combination in this case. And what makes a neural network architecture good is because the researchers have done a lot of experimentation and discover some sort of architecture. This is a neural network, and that's the architecture I just built. It has 6 hidden layers, and in some of the layers, it has 8 neurons, right? And each one of these neurons has data passed through this neuron, right? It's going to do some simple transformation and some calculation. And so each neuron accepts input and it spits out output that feed into the next layer. And the feeds feed into all the neurons in the next layer, okay? And that's why this computation graph is very complex. And when we say that a neural network has a lot of weights, right, that's basically what we mean here. There are a lot of connections among different neurons across different layers. And that's what make the neural network model harder to train, because it's just more complex than the traditional algorithm. Okay. But searching for the best neural architecture is a research topic on its own. And some of these famous architecture has been proven, right, to work really well, but it doesn't mean that it's the best. There might be architectures out there, and there are researchers doing this, all the time, just trying to discover new architecture. Okay, but this is how we can build a neural network. Right, we basically create the layers and the number of neurons. And then there are some other parameters we need to set. So for example, the learning rate, the activation functions. The learning rate decides how fast you want the models to learn, right? And activation happens inside each neuron whenever it receives some sort of input, okay? It's going to do some sort of transformation, okay? And sometimes it learns more, and sometimes it, decides to ignore what it learned because it's not important. But how does it decide what's important, what's not important? That's the weight. So when companies open source a large language model, they open source the weights. And this is basically all the neural network weights saved in a text file, basically. And then they share and open source that. And other people can load all of these weights into their computer. And using the Hugging Face library, they can basically leverage that open source model to generate prediction. So the knowledge, right, ChatGPT learned from all the web data is basically compressed into these neurons and weights. And that's essentially how it works. But I think the secret sauce is how we generate these weights and how we design this architecture so that it becomes a very powerful model, right? Because it's very simple for anyone to have their own architecture, but most of the time it's probably not going to work as good. Okay, so I think if you want to work as an AI engineer, it's more about how you choose these hyperparameters, right? And need to understand, when to use ReLU, when to use sigmoid, or when to use a linear transformation function, right? And of course, the problem here is simple. We're just trying to do either classification or regression. But when you apply that to, LLMs or, computer vision, it might be different types of tasks. Okay. But that's it. That's how we, train a neural network. I just need to click on this run button on the top left. Okay. And then it starts the training process. Each epoch here, it just means how many times it goes through the data point, all the data you have. And here you'll see the loss, right? And the training loss and test loss. Loss means the mistake. We're hoping to see the loss just decreasing. Means that it makes less mistake. Ideally, the loss is 0. But your model gets trained on training and it's validated on test, right? So you're hoping that your model learn from one data set, and when you apply this model, learn the model, right, to another data set, it can maintain the same level of performance, right? So if it does very well on your training data, and when you use this model to generate predictions on other data sets and it does poorly, that's not a good model. We want the model that can generalize really, really well, right? The reason why ChatGPT can answer so many, like hundreds of millions of people's questions, and most people are still kind of happy with the performance, it means the model is like validated really well, right? It has seen so many different kind of questions and so many different kinds of text. Okay. The Google Gemini model recently, got some backlash because of the bias in its like prediction, right? So when you ask it to generate an image about let's say Elon Musk, and it's generated like a black Elon Musk, right? So that creates a lot of problems, right? Some people are not happy about it, but what's causing this? Well, validation is part of the process, but also what kind of data you feed into the learning process is very important. Okay. So if you want to generate very powerful AI and machine learning models, the data you pick, the data you process and prepare, and the way you validate the models, and these are actually the very practical things you need to consider. And the algorithm itself, most of the time, we're just using open source algorithms. So you're much less likely to build your own algorithms. Okay. You're just leveraging these algorithms, but it's the data preparation that's more important. Okay. All right. So that's hopefully that's an interesting use case to help you understand how machine learning systems learn, right? And as you can see, we are classifying the images into blue and orange, right? And each neuron here learns something different. Okay. And all of these weights combined through this network allows you to generate very powerful prediction. Okay. I think we over-engineered this system in this case. It's not doing a very good job. If we simplify this neural network architecture, it can actually do a much better job. So this is called overfitting. Your system might be just too so let's reduce the hidden layers. Okay, and reduce the number of neurons, it might actually perform better. Okay, so let's give it another try. As you can see, it learns much faster this time. We're going to be looking at this here. Okay, and now the training loss is quite a bit lower, but test loss is still like kind of struggling. Okay, that's where you're going to tune this and hopefully it gets better. But as we can see, in terms of the separation, that's really doing a pretty good job already. Okay. All right. I'm going to stop here. I think it's time to take a break. When we come back from the break, we'll take 10-minute break. When we come back, we'll continue to discuss generative AI and large language model. We're going to spend a lot more time focusing on LLMs. We'll go through the history and help you understand, how that works at a high level. Okay. Now let's move on to generative AI. So before the break, we covered AI, machine learning, deep learning, and we know that generative AI is part of deep learning, and it has a lot of generative use cases. For example, we can use generative AI to generate not just text, but generate image as well. Right? So here's the latest example, which is Sora, which is text to video generation. So you can basically do text prompting and it generates a video. Some people got scared by how good it is, right? But I don't think it's good enough for you to produce like a real movie. But I think the technology is getting there. But I think there's so many movies out there and videos, and what makes a movie sell very well is not just the video itself; it's the whole storyline. For AI to generate a storyline that really that interests us, I think it's not that easy. But we'll see. These tools can definitely help you save a lot of time, and it's doing a really fantastic job. And if you're more interested in the technical side of this, but it's basic text to video prompting. To understand how Sora work actually definitely requires you to understand the fundamentals of transformers, vision transformers, and also computer vision. So we will not be discussing this in detail, but I included a link in case you want to take a look at the Sora architecture. Okay, today is still very high level introduction. There are different types of learning mode, right? So there's the descriptive models where you can do classification. So you show a picture of a cat, and you want the machine learning model to sort of just classify this image and say, is it cat or dog, right? But generative AI is more on the generative side. So we use text prompt, right? We want the algorithm to generate an image of a cat. But of course, it can generate many different types of images, and it depends on the prompt. How you prompt the system is very important, and it can give you different output, right? But still, we need to understand that the limitation of these systems is that it can only do generation based on whatever it learns from the training data, right? So if your training data is built differently, then its capability will be very different when it comes to generation. And that's why in the early stages of like a Mid-Journey, and people start to realize that, well, most of the images have very similar style, and it looks all very similar, right? And that's because of the training data. So I think now it gets a lot better and more powerful. Okay. So the question is, the traditional machine learning and deep learning models require a lot of labeled data for training. So, we feed these kind of images, such as blueberry muffin, chihuahua images into the system. But these images require label or annotation, right? You need to tell the machine learning algorithm that, well, the first picture is chihuahua picture, the second picture is blueberry muffin, and every image you feed into the computer vision, whatever deep learning algorithm, you need to tell it the label, whether it's chihuahua or blueberry muffin. Right? So that requires us to label the data, and it cannot learn automatically, right? This is actually different from how human or the babies learn, because a newborn baby, right, after a couple of days or weeks, it will start to sort of know, the difference between mom and dad, for example, maybe after a couple of months. But at that point, they don't even speak any language yet, right? They have not learned language properly. So you can't really prompt them. You can't really tell them or teach them that, oh, this is, this is cat, this is dog. But how come they can actually sort of just learn from the environment, and they will be able to tell the difference, right? Or when they start to learn how to walk and they fell, they feel the pain, and the next time they will know how to sort of avoid the mistakes, right? You can't possibly label everything, and that's actually what stops the traditional or classical machine learning models from being like very useful in some of those use cases. Okay. So we need to label lots of data, but how do we do the data annotation? There are different ways. We can manually label the data, but that's not very scalable. Right? We're talking about maybe millions of images and millions of videos. So there are annotation services out there, such as Amazon's Mechanical Turk, right? So later on, we will learn SageMaker Canvas. I can briefly talk about how we can use the ground truth service to label the data, but you have to pay for those services. OpenAI leverages human annotators a lot. They paid a lot of money on data annotation. But before you can train these systems, you do need data annotation. But the challenge here is, how do you scale, annotate and label these data at scale, right? So, let's say you spend millions of dollars labeling, let's say, millions of images. That's great. You can build a very powerful computer vision model. But still, it only learned from those 1 million images, right? So that means in many use cases, it's not going to do very well, like do prediction very well, if the image it's trying to classify is not in the training data. The real world is way more complex, right? So how do we solve that problem? So we cannot label all the data we have on the internet, right? So a better way is, well, why don't we just not stop thinking about labeling all the data, right? Maybe we can just do self-supervised learning, which requires basically no data annotation, okay? just like how babies learn. Self-supervised learning is what actually helped LLM had the initial breakthrough, because now we're talking about large-scale training instead of large-scale data annotation. So before this, I think the biggest limitation is just, if you want your model to become really powerful, then you need better and high quality labeled data. But that cost is very high, and also it's impossible for it to label everything. And there are new things that when we see them, we sort of can learn very quickly. But the machine learning systems also have to label the data first, and they have to retrain your model. So that slows things down. It cannot learn something really quickly. So the best approach, or a better approach, is just do self-paced, or self-supervised learning. Okay. This is how it works. So let's say we want, let's say ChatGPT to do the completion, right? So we prompt nothing is, and then a large language model will be able to predict the next word. And then it will say, okay, nothing is impossible, right? So the way we built this kind of training data is that it's called self-supervised learning, because we can construct the training data automatically by just looking at the next word, right? But we can go back and for example, when we built the training data set, first we start with nothing, right? And then there's nothing is. Okay, so that means is usually comes after nothing. Okay. And then when you have nothing is, you have a new training data, and the context here is, nothing is, and then the next word is impossible. That's how ChatGPT talks. If it has seen like millions of examples when people mention nothing is impossible, nothing is impossible, then it starts to think that, well, after nothing is, it's quite, it's still statistical, right? You understand that it has a much higher likelihood to be impossible, okay? Or it could be nothing is working. People are complaining, right? So there's a likelihood that it's going to be nothing is working. Then which one do we prefer? Are we going to pick nothing is impossible or nothing is working? Well, you need the context. What was the sentence before this, right? Now we're starting to talk about the context window, right? That's why when people talk about, generative AI, ChatGPT, it's all about the context window, and the new Google Gemini can feed like the entire book into its context window. And ChatGPT used to have some limitations, right? The token size. So the more context it has, the better prediction it can make, right? But in order to train this kind of model, we can't label all of these data. We have to use self-supervised learning to label the data, and then we'll talk about that briefly shortly, okay? So generative AI, again, it's a machine learning system, and it requires typically input, and it gives you output. But unlike the traditional machine learning, input doesn't have to be, a table or structured data. It could be text. So in this case, we use text prompt, right? Draw me a chihuahua that has yellow fur, cyberpunk style, sitting on a blueberry muffin, blah, blah. That's the prompt. And you feed that into a generative model, and it gives you the image output, right? But generative AI is more than just text to text, text to image prompt. You can do image to text, you can do image to image, right? And text to video now with Sora. There are many different use cases, okay? So some examples, text to text, right? So we can do machine translation, for example. Text to image, we've just seen an example, right? Text to videos, that's Sora. And text to task, if you're building some sort of agent, right? And again, the task could be generating a prediction. The task could be calling an API to do something. And it all depends on how you're going to train the model to achieve this kind of tasks. Okay, so that's generative AI, right? Just in summary, the traditional machine learning requires a lot of labeling, and labeling very expensive, right? So it's not that scalable. If we're just predicting customer churn, predicting some sort of sentiment, those are considered as easy tasks. Okay, so it doesn't require a lot of training and labeled data. But here, If you want to do generative tasks, we have to think about different approach. And self-supervised learning is better because we can construct the training data automatically, and that's the large language model pre-training. If it's text to text, right? We'll talk more about this when we talk about LLM. Okay. And then generative AI again requires input output, and the input and output can be different things. Okay. Now let's move on to large language modeling. It's it's part of generative AI because it's generating text, right? Sometimes text to image is also based on LLMs, at least using LLM as part of the equation. So here we can use, let's say we can prompt, right? So text prompt is the input. And as I'm asking a question, fill in the blank for me. Below, Dubai is the most city in the world. And then you're basically asking ChatGPT to do the completion, right? What is the word? It's going to choose. In this case, it choose futuristic. So it's the most futuristic city, but you can have other alternative words. But it all, like the probability here of generating the next word really depends on the training data and how the model learns, right? And it depends on the context. Because if you change the city name, then for sure it's going to change the word completion here. Because if you change that to Shanghai, to Toronto, to New York City, right, San Francisco, then the word might be different. We'll do some practice in the lab today. Okay. So there was a question. Are you saying Gen AI still needs to be trained, pre-trained model, but unlike traditional supervised learning, it doesn't require manual labeling? Is that right? Not all generative AI. So here we're talking about generative models. The commonly used generative models, such as GPT models and the vision trend, these models are actually called self-supervised learning. So it doesn't require a lot of annotation, but labeling is involved in this. I'll talk about pre-trainings and fine-tunings today, and you understand the steps. So the most expensive part is the pre-training. The pre-training, we're talking about pre-training here. That is self-supervised, which doesn't require like labeling. Okay, you just need to dump compute and money into it, and you just need very well curated and prepared data, and then you will be able to build your large language model, pre-trained model easily. But the reason why only a few companies can do that is because only a few companies have the money and also the scale, like the data here. Okay, but pre-training itself is not hard because there's no secret sauce here. But the hard part is the data preparation and then how you fine-tune a model later. Okay. Because we'll talk about the size of the models. All the details are later, but you'll realize that it's impossible for you to label all of these data, and then you have to find the self-supervised learning, which doesn't require labeling, and that's when we had the breakthrough here with the GPT model. Okay, because the algorithm is nothing fancy, nothing new, but people used to think that you need a label, but once you get around that problem, all of a sudden you're able to scale. Right? You can scale because the model just construct the label on its own. But then the challenge was, okay, do we have enough GPU? Do we have enough compute power? And now that problem is solved. And when you have the money, you can train powerful model. Okay. All right. So LLMs, we have text input, we have generated output. You can do text to text, but you can do image to text as well, right? If you upload that same image to DALL-E or Midjourney and say, describe this image for me, then it's actually going to generate some sort of text output, which is generated. So that's why it's called generative model. It generates output from you instead of just performing, just following the instructions to say, is this dog or is this cat? Is this Chihuahua or Bluebird Muffin? So for those type of classification model, it's supervised because you're giving instruction. You're saying that, okay, this is a cat image, this is a dog image, right? I give you many examples. Now here's a new image. Tell me whether it's cat or dog. But with generative models, you're just uploading an image and say, generate some text for me, right? And different models and different parameters you put into this model can generate very different output. Okay. And one of the biggest challenges with generative model is how to evaluate, how well the output is. We'll talk about those challenges, because if you're doing fraud detection, it's very easy to validate. So is it fraud or not? Or is it cat or dogs? And you have a lot of labeled images already. And that's why you can do model evaluation or validation easily. But with generative model right now, the biggest challenge is how to evaluate the models. And we'll talk about those challenges, okay?